All right, you guys, so I know that you're dying to put all the factoring techniques we talked about together into one problem, right? I know. Okay, so what I have for you is all the factoring techniques that we have talked about organized into a nifty chart, which this chart is in your notes or foldable, so you don't have to copy it down right now. So when we are factoring, it's always based on how many terms you have. That will tell you what factoring technique to use. Now, something you cannot forget, no matter which factoring technique we use, always try to factor out a GCF first. Always. Now, if you have two terms, we have three options. A difference of squares, if you are subtracting with two numbers and have two perfect squares, that tells you to use difference of two squares. If you have a difference of two cubes, so two numbers that are subtracting and are perfect cubes, you can use a difference of two cubes. Or a sum of two cubes, if you have two perfect cubes added together, you'll be using a sum of two cubes. So these are all the ones you use if you have two terms. Now if you have three terms, okay, you can always do the quadratic formula no matter what. Okay, and then sometimes you can do the slide and divide technique, which is our general factoring technique. Okay, but sometimes this technique does not work, which means we have to use the quadratic formula, which this one always works. And lastly, if you have four or more terms, you will be doing group factoring. So we're always going to be addressing this chart when we're figuring out which factoring technique to use. Okay, so on this one, what I'm going to do first. Okay, I'm going to factor out a GCF first if I see one. So let's see if we spot a GCF. All right, so are there any variables that are in both terms? Holy hot dog, I see it too, you guys. It's the A's. Okay, so I need to think about what's the largest amount of A's that I can grab from each term. You guys are way too smart. I shouldn't even be doing this problem with you. It is A squared. Guys, and remember, the rule of thumb, you grab the one that is smaller. So A squared is smaller. All right, let's see what we have left let's see what's left after we divide by the GCF. All right, guys, a to the 8th divided by a squared. Remember, if we have variables with exponents, we subtract the exponents. So 8 minus 2 is 6. So this is a to the 6th. Okay, and then over here, okay, we have an a squared divided by a squared, so those will cancel out, and we're left with a negative b to the 6th. Okay, so we did the GCF first. Okay, so this step was the GCF. All right, from here, we are looking inside of the parenthesis to figure out which factoring technique we could use next. Okay, so I have two things that are subtracting. So if I look back at my chart, I'm going to go to two terms because I see two terms. The only ones that involve subtracting are my differences of squares and my differences of cubes. So I have to figure out which one this is. And the way you do that, you guys, is by seeing if you can square root each piece or if you could cube root each piece. Okay, so let's see what happens. Can I square root an a to the 6th? So remember, when you guys square root variables with exponents, you divide by the index, which the index of a square root is 2. Okay, which I can divide both of these 6's by 2's. So this is a difference of squares, you guys. But now let's just think about, is this a difference of cubes? Let's think. So a difference of cubes, the index is 3. So could I divide each of my exponents by 3? Oh no, I can. So which one do I use? Do I use a difference of 2 squares or a difference of 2 cubes? Because it works with both of them. Well, if this happens to you, if you can use a difference of squares and a difference of cubes, what you have to do, you must do a difference of squares first. Okay, you always do the difference of squares first if it is both a difference of squares and cubes. I'm telling you right now, you will not get the right answer if you do a difference of cubes first when it is both a difference of squares and a difference of cubes. It will not work. Okay, so I'm going to do the difference of squares first, and let's see what happens. Okay. Alrighty, so the difference of squares says we're going to square root each of these pieces and then add and subtract what we get. So let's see what happens. Okay, so my a term, I'm going to square root the a to the 6th. And my c term, I'm going to square root the b to the 6th. Which, remember you guys, there is secretly a 2 lurking in the index. And that is what we divide each of our exponents by. So 6 divided by 2 will give me 3. So this is a to the third. And 6 divided by 2 will give me 3 again. So this is b to the third. All right, and what the difference of squares says to do is to add the a and the c and subtract. Okay? So I'm going to add my a and my c. So I'm going to add my a cubed plus my b cubed. And then I'm going to subtract my a cubed and my b cubed. Okay, and I cannot forget about my GCF, so I'm going to bring it down before I forget about it. Don't forget about the GCF, which is an a squared. And actually, I'm going to do it in purple so it looks different than all this. Okay, so when you guys are doing this, you always have to ask yourself, could I keep factoring? And I hope we can, you guys, because we love to factor, right? I know I do, so I hope you like to factor as much as I do. Okay, so each time you guys break it down into more and more parentheses, you have to ask yourself, could I keep factoring? Okay, so let's look at each of these real quickly. All right, I got an a cubed plus a b cubed. Now, the only thing that has an addition, it has two terms, so I'm going to go to my two terms category. The only one that has a sum involved is a sum of cubes. So let's think, could I do a sum of cubes on this one? Which, for a sum of cubes, you have to be able to cube root each piece. Which, remember, there's a 3 in the index, so I know that says 2, but in a cube root, there's a 3 in the index, which means we will divide the exponents by 3. Will 3 divide into 3 and 3, you guys? Absolutely. So this one, a difference of cubes will work. So on this one, we're going to use a difference of cubes. I'm sorry, not difference. Sum. Sorry, it's a sum, not a difference. So what the sum of cubes says is we must cube root each of those. Also, that's what a difference of cubes says, you guys, so that's why the wording is confusing me. So this is a sum of cubes. Sum of cubes. Okay, sorry about that. Okay, so since we have a plus sign, and since I can cube root each of these, this is going to be a sum of cubes. Okay, now the second parenthesis, I have two things that are subtracting. So let's go to my two terms. Okay, the two things that are subtracting are a difference of squares and a difference of cubes. So let's see which will work. Okay, a difference of squares, I have to be able to square root each of these. Okay, which in a square root, there's a 2 in the index, so I have to be able to divide the 3 by 2. Okay, which I cannot successfully divide 3 by 2 and get a whole number. Okay, so this is definitely not a difference of squares. Okay, but a difference of cubes says I have to be able to cube root each of these. So remember, cube roots have a 3 in the index, so I can divide 3 by 3. So a difference of cubes will work on this one. Okay, so on this one, we're going to do a difference of cubes. Difference of cubes. So we're going to be factoring 2 more times, you guys. On this one, we're going to do a sum of cubes. And on this one, we're going to do a difference of cubes. Okay, which I'm going to kind of do them at the same time because, first of all, my letters are pretty much the same. I got A's and B's, and they're both to the third power. And secondly, a sum and difference of 2 cubes, we always start off doing the same thing. Okay, and our formulas are pretty much the same. So we're basically going to be getting the same answers for each of these, just our signs will be slightly different. Okay, so let's find the A and the C. Okay, so the A on this one, we have to cube root the first term, which is A to the third. And the C, we're going to cube root the second term, which is B to the third. All right, and same thing on this one, you guys. The A, we cube root the first term, which is A to the third. And the C, we cube root the second term, which is, remember, we ignore the negative when we do this, so it's B to the third. So do you guys see how I have the same numbers in here? So we're going to get the same A and C values. So remember, when we have variables with exponents, we divide by the index. So 3 divided by 3 will give me a 1. So this is A to the first, or just A. And again, 3 divided by 3 is 1, so this is B to the first, or just B. Same thing here over here, you guys. 3 divided by 3 is 1, so it's A to the first, or just A. And 3 divided by 3 is 1, so this is B to the first, or just B. Alright guys, after this we just do our formula. So a sum of cubes tells me to add the A and C first. Okay, so I'm going to do, first of all though, I'm going to bring down my GCF before I forget it. My A squared I'm going to write first. Okay, it says to add my A and my C first. So I'm going to add the A and the B. Then it says to square the A term. So I'm going to square A, which is A squared. Then it says to it says to subtract my A times my C. So my A times my C, A times B will give me a AB. So this will be minus AB because we subtract AB. And then lastly, we square the C. So B squared is B squared. Holy hot dog. Okay, so this one is factored. Awesome. All right, and then remember, a difference of cubes is the same exact formula as a sum of cubes, just the first two signs are opposite. So I'm going to flip my signs on the second one, and I'll be done. Okay, so my A plus B for a difference of cubes will be an A minus B. And then remember, this sign is the opposite. So instead of a minus sign, it'll be a plus sign. And remember, this last one's always a plus sign. The last two are always positive. So this will be A squared plus AB plus B squared. Alright guys, now, usually at this phase, in all the parentheses, you would ask yourself, could I keep factoring? Now, I know that these two have 3 terms in it, so we're tempted to do this, slide and divide, or the quadratic formula. Okay, but once you do a difference or sum of cubes, you cannot factor any further. Okay, so we can do no more factoring at all. Okay, so all of the quadratic formula, this isn't really factoring, you guys. This is more solving for zeros. So we would have to be able to do the slide and divide technique, which we cannot do. Technically, we can use the quadratic formula on sum and difference of cubes, okay, but we're not trying to find zeros at this point. We're just trying to find factored forms. So after we do a sum or difference of cubes, we can no longer factor. So after we've done that, we are done because I did a sum and a difference of cubes and I can't do anything else. So all of this would be my final answer. Isn't that exciting, you guys? That was so much fun.